These are proofs involving congruent triangles. This is problem type 4. Again, we're following GIFT. Given, implied, freebies. We're going to talk it through. Let's look at our given information first. We're given that segment DE and GH are congruent. So DE and GH are congruent. That gives us a pair of sides. We're also told that DE and GH are parallel. Whenever we have parallel lines, I always like to extend the parallel lines. So draw the diagram, get out your ruler, and extend the parallel lines. It's a little bit easier to see what you're working with. We're told that DE and GH are parallel. So do the little arrow feathers. That implies those segments are parallel. So we are done with our given information. Let's look at what we're trying to prove. We're trying to prove that DF and GF are congruent. Somehow we're trying to get those segments congruent. Well, if we can say that these two triangles are congruent, let me highlight them. If there is a way to get these two triangles congruent, triangle EDF and triangle HGF, if there's a way to get the triangles congruent, then we can say the parts are congruent. And triangles congruent, parts congruent. The standard way of expressing that in geometry is corresponding parts of congruent triangles are congruent, also known as CPCTC. So let's see if we can get the triangles to be congruent. Let's look at our implied information. What's implied? Well, if the lines are parallel, then we know that armpits of the Z are congruent, also known as alternate interior angles are congruent. So we can do this, and we can say that this angle D here is congruent to angle G. That gives us a pair of angles. What we also know is, that's implied, freebies, is that this angle in the middle on one side is congruent to this angle over here. Those are vertical angles. And those are freebies, which means they're always true even if they're not in the given information. So we see that we can create this triangle EDF is going to be congruent to HGF by angle, angle, side. And if the triangles are congruent, then we can say the parts are congruent. DF is congruent to GF. So let's see how this looks in the actual proof. Let's go to our given information. DE is congruent to GH. We know that because it's given. DE is parallel to GH. We know that because it's given. Once again, if these are parallel, then the alternate interior angles are congruent. So we're going to be very careful here. Our alternate interior angles are going to be EDF. That's that angle right there. So we're going to pick this up. Angle EDF is congruent to angle HGF. That would be the alternate interior angles, armpits of the Z, HGF. And the reason for that is if you have parallel lines, then alternate interior angles are congruent. If parallel lines, then alternate, make sure you get interior angles are congruent. It wants to know, where do you get the parallel lines? We get parallel lines from step 2. So far we have a pair of sides congruent and a pair of angles.